As we continue with factoring, we're going to talk about factoring by grouping. And this is really factoring a higher degree polynomial. But I sort of reordered this to where we talk about this because it's going to help us when we are factoring trinomials, quadratic trinomials, and because one of the steps is to go ahead and factor by grouping. So just looking at it, sometimes when we start to factor, we want to factor out the greatest common factor if there is one. And so if I look at this first example, I'm going to, what is the factored form of this this polynomial, which is 3n cubed minus 12n squared plus 2n minus 8. And there is nothing in common. There's no numbers or variables that each one of these have in common. And as a higher order, what I can do is looking at factoring by grouping. What we want to do is we want to take, I have this first two terms, and if I look at those, it turns out that, yeah, there's something that we could factor out of those individually. And then we have these second two terms. So I'm going to find the greatest common factor of each one of these pairs. So in doing so, I know that in this first group, I can factor both of these by 3n squared, it looks like. I'm able to factor that out of both terms. So that would be the greatest common factor of those. So I have 3n squared, and then leaving behind n minus 4. Okay, so if I factor out 3n squared from both of those terms, it leaves the binomial n minus 4. And if I turn around and I do the same thing over on this other second set, the greatest common factor there, it turns out, is going to be a positive 2. And lo and behold, look what happens when I factor out a positive 2 from each one of those. I have a n minus 4. So factoring by grouping, I'm able to find my two binomials here. I'm able to actually factor out a greatest common factor, and reversing the distributive process, I'm able to come up with my other binomial. One binomial was previously identified, right? And then the other binomial is going to be 3n squared plus 2. And I have factored this by grouping. One thing you want to do when you look at this, though, clearly this is prime. N minus 4 is a prime factor, but because I have n squared on my other factor, you want to make sure that it's prime, and looking at it, I don't have anything in common that I can further break that down. So yeah, my factored form of that cubic function, cubic polynomial, is going to be 3n squared plus 2 times n minus 4. So we are factoring by grouping, and what you notice is we take the first two terms and we can factor those out, and then we take the second two terms and we can factor those, and let's just see where it goes from there. So what is the factored form of 8t cubed plus 14t squared plus 20t plus 35? All right, so again, taking the first two terms, and we're looking at the greatest common factor, which happens to be 2t squared. And I can factor out of both of those terms 2t squared, so I have 2t squared, leaving behind 8t cubed divided by 2t squared becomes 4t, and then plus 7. And if we've done it right and everything works out, what I have in that binomial is actually going to be the same. And again, so looking at the greatest common factor here of 20t and 35, it should be 5. So if I factor out a positive 5 from both, sure enough, I end up with 4t plus 7. Now, I already know that I have 4t plus 7 as one of my prime factors, and then my other prime factor is going to be what I'm distributing into that, 2t squared plus 5. So there you go. There's my prime factorization of that cubic function, or cubic polynomial, and it would not have mattered, or it would have mattered, I guess. You could have possibly factored those in different ways. Depending on how you grouped them, you could have still received the proper answer. Okay, so let's see here, factoring a polynomial completely. Well, looking at this, this is what is this factored form of each expression? Well, again, the first thing I want to do, I want to look for a greatest common factor. And if we look, we do have 4q to the fourth minus 8q to the third plus 12q squared minus 24q. If we look at each one of these, we should be able to say, hey, they each have a greatest common factor that we can factor out. And I hope that you can see that we can factor out 4q from both of those, or all four of those, sorry. In doing so, that simplifies to, looks like q, I'm going to factor out, 4q, and leaves behind q cubed minus 2 cubed squared plus 3q minus 6. And now that was my first step. I looked for that greatest common factor. Now I look at this, and I do have a higher order polynomial. It's cubed. And, and looking at it, could I do some factoring by grouping? Well, I could take these two, and I could take these two and do some factoring. So again, I have 4 cubed. And then factoring out from the first expression, I can factor out a cube squared, and that leaves behind q minus 2. And if I did it right, I should have the same thing over here. And looking at 3q minus 4 right here, what do they have in common? Well, I can factor out a positive 3. So if I do, I end up leaving behind q minus 2. So then when I do my factor by grouping, I have 4q times q squared plus 3 times q minus 2. And there you have the factored form of that fourth degree polynomial up here, right there. So the reason I use brackets here didn't really matter. What I was trying to do is distinguish that I still had this operation going on, and I didn't want to accidentally multiply these two, and just sort of distinguishing between my parentheses, because a parentheses within a parentheses can sometimes be confusing. Okay, so let's see here, moving on to my next example. And when I look at a problem like this, when I see 4 terms, I should be thinking that I'm going to factor by grouping. But also, of course, that first thing I'm looking for is a greatest common factor, which it looks like they all have an h as a greatest common factor, and they also can be factored by the number 3. So when I factor out that, I get 3h, and then what gets left behind, I have 2h cubed plus 3h squared plus 4h plus 6. And now factoring by grouping again. So I have 3h. And then when I factor my greatest common factor out of here, it looks like I can factor out h squared from both of those. So I have h squared times 2h plus 3. And again, if I factored out by grouping right, these should be the same. And then if I can factor out of both the second terms, the greatest common factor is going to be 2. So factor out of 2, and it leaves behind 2h plus 3. So my factored form turns out to be, remembering I got this and I got this. Well, we know that 2h plus 3 is one of our factors, and of course the other factor is going to be what you've factored out. So h squared plus 2. And there is my factored form of that higher degree polynomial. So again, looking for the greatest common factor, then factor by grouping if you have four terms there, and then seeing if you can simplify further. So looking here, finding the dimensions of a rectangular prism. The dimensions of a rectangular prism. Well, a prism, you should know and you should be able to visualize, is going to be a three-dimensional item. So that's going to give depth, and that's not a very good one right there, but that's going to give depth. And so if I have a prism, I'm going to have a length times width times height. So I should be looking, some form of volume, right? Length, width, and height is going to be that rectangular prism because it's usually the area of the base times height. So a rectangular prism has a volume of this, 60x squared, 60x cubed plus 34x squared plus 4x. And what expression can be represented in these dimensions? Well, what expression can represent these dimensions of the prism? Well, if I'm looking for length times width times height, I'm looking for three things that are being multiplied together. So that tells me I should hopefully say, hey, I got this polynomial, and let's see, can I factor it some? So looking at this, I should be able to say, well, first off, I do have a greatest common factor of all of these. And it looks like they're all factorable by 2x. So if I factor out a 2x from each one of those, that is going to leave behind 30x squared plus 17x plus 2. Now, I'm trying to think, as we move forward here, what can I do to continue factoring this? Because it looks like I have one of my prime factors right here, and that's going to be 2x. But I need to break this down into some other factor. So we're going to do a factoring by, we're going to factor this trinomial. And we have talked about this some in class, but I'm going to factor this middle term. And I'm going to take that middle term and I'm going to split it up into two terms, reversing the multiplication process and the combining like terms process when we are multiplying binomials. And I'm going to split that up, and I'm going to say, okay, if I multiply a times c, which in this case is, this is my a, b, c. A times c is going to be 60. And I want the factors of 60, right? What times what will give me 60, but will also sum add to be 17, because I want it to add to b. And the factors of 60 that will give me 17 are probably going to be 5 times 12. So I'm going to split that 17x up into 5x and 12x. So I have 30x squared plus 12x plus 5x plus 2. Now, the only thing I have done here is I have uncombined. I've separated my like term. The value of the trinomial is still there. I haven't changed the value of it. 17x, 12x, and 5x added together is 17x. The value hasn't changed. I've just changed the way that it looks. So I can now factor by grouping because I have three terms. And in doing so, I should be able to say, okay, well, what expression, what factoring by grouping, what's my greatest common factor out of the first two, greatest common factor out of the second two. Out of the first two, it looks like I can divide both of those by 6x. And if I factor each one of those by 6x, then I have left behind a 5x plus 2. Lo and behold, looks like that is going to be my other. I have 5x plus 2, but my greatest common factor between these two currently is, I don't see anything but a 1, right? So I can factor out a 1. And then when I rewrite my binomials, I have one binomial there, and then I have the other binomial right here. So my factors for this are going to be 2x times 6x plus 1 times 5x plus 2. And that is going to be the volume is equal to 2x times 6x plus 1 times 5x plus 2. Okay, and there we have, it turns out we have a length, a width, and a height. And any of those could be any of those measurements, but we found the three factors of that trinomial. And taking this last one into account, it says this another rectangular prism, so we have the volume, and we were looking for the volume is length, width, and height. So let's think, how can we factor that? We hopefully see that they all have a 3x in common. So if I factor out a 3x, that leaves behind, we have 3x, and we have a 2x squared. Oh, goodness gracious, look at that. I can't factor out a 3x. 19 is not divisible by that. So I'm going to just factor out x. So if I factor out an x, that leaves behind 6x squared plus 19x plus 15. And here we have it. We have a trinomial, which we're going to continue to factor because we want to split that up into two terms to where we can factor by grouping. And what I'm going to do is take a times c. So I have a times c, which is going to be 6 times 15. 6 times 15, which is going to give me 80. And I want to know the factors of 80, which will add to be 19. And I don't know. Factors of 80, which add to be 19. Well, first of all, I can probably fix that. That's not 80. Sometimes I do make a mistake. A times c, 6 times 15 is actually 90. So what factors of 90 which will add to be 19? Well, that's 10 times 9. So we can split that 19x up into 10x and 9x. So we have 6x squared plus 10x plus 9x plus 15. Wouldn't matter which order we put the 10x and the 9x in. It's all going to work out. So we're going to factor the first two and the last two terms. And the greatest common factor of 6x squared and 10x is going to be 2x. So if I factor out a 2x, that leaves behind 3x plus 5. And then if I factor out the greatest common factor of this other term is going to be 3. So factor out a 3, and that leaves behind 3x plus 5. And sure enough, it's looking like it's going to work, right? So I have one binomial there. So I have x times 3x plus 5, right? And then 2x plus 3. There you go. Volume equals x times 2x plus 3 times 3x plus 5. And that is factoring by grouping and taking a polynomial, creating its prime factors. Remember that you always want to look for your greatest common factor first. That's the first thing we do to make it easy on us to get that out of the way. And then as we factor our trinomial, we may have 4 terms or 3 terms and make 4. And again, this is just some practice. Factoring is the bread and butter of math, being able to factor and multiply binomials and trinomials, because you're going to be doing these simplifications, and it's incredibly important as we move farther along in math that it just makes it easy on you to be able to factor a polynomial because you make your problem smaller, factoring out the value of 1. And so doing that, we will go ahead and do some practice in class.